So I'm going to show you an easy way to solve the LeetCode problem number 133, and it says clone graph. So basically you're given a graph like this one and you simply have to clone it. The method we are going to be using here is called recursive DFS. So what does it mean? We are simply going to actually be cloning each of the nodes one by one. So basically what I want us to do is to take this node 1 with neighbors 2 and 4, and we have node 2 with neighbors 1 and 3, and node 4 with neighbors 1 and 3, node 2 with neighbors 1 and 3, and node 1 with neighbors, the neighbors for node 1 is what? Is 2 and 4. So they want us to take this information and then build up a new graph one by one. So clone these nodes and put the neighbors there, clone this one, put the neighbors there, and so on. So they want us to use a building block to build up a new graph. So they don't want us to just do a copy like this, and they don't also want us to do a clone like this where the nodes are reversed. Like in this case, we have 3 here and we have 2 here. It doesn't work. So they want us to create a new graph using this information, right? One by one. So what we are going to be using to solve this problem is a dictionary that's going to hold information about the old graph and information about the new graph. So basically, let me show you how the algorithm works. So we are going to start from node 1. We have node 1, this is node 1, and we simply create a copy of node 1. If node 1 is not already existing, we simply create a copy of node 1 here in the dictionary, like this. The next thing we are going to do is to now get all the children or all the neighbors of node 1 and also clone them recursively. So it's going to be 2 and 3, like this. And then we are going to move straight to node 2, which is this one, and then we are going to do the same thing we did in node 1. We are going to check, does node 2 exist in the dictionary? Of course, when we clone this one, we're also going to have clone this one as well, and this. So we are going to check node 2, does it exist? Yes. So we move to the next node, and in this way we do do it for the whole node recursively. And this is basically it. It's not so extraordinary. It's something quite intuitive and clear. So let's write the code, and you see that the code actually follows exactly from the way I explained it. So let's start by creating a dictionary. Let me shift this one a little bit away from here. So I'm going to start by creating a new dictionary. So I'm going to call it an empty dictionary like this, and I'm going to create a function that's actually going to do the cloning. So I'm going to call this function clone, and it's going to take a single node and clone it. So this function is going to be called clone. It takes a node. First, it's going to check if the node is in the dictionary. So if nodes in D, then we are simply going to return that node. Actually, we are going to return the clone of that node or the copy of that node. Return D of the node. Else, it's not there. We are simply going to make a copy of that node by creating a new node using the constructor. And so it's going to be node. This is a constructor, and it's going to take node.val. And yeah, so let me kind of make room here. And after that, we are going to add the node to the dictionary, or that copy to the dictionary. So it's going to be D of the copy. Sorry, D of the nodes is going to be equal to the copy. Okay, so now we are going to recursively now do the same thing for the children or for the neighbors of the current node. So I'm going to run a for loop that says, let me just make room here, for ne in node.neighbors. So what are we going to do? We are going to do exactly the same thing. So we are going to call recursively this function and add all these neighbors to the as neighbors to this copy, right? So I'm going to say copy dot neighbors dot append. I think it's going to be append, and I'm going to say clone that particular neighbor. So this is a recursive call to all the neighbors of the current node, and it's going to clone them and add them as neighbors to the copy. So at the end of the day, we are going to simply return the copy from here. So I'm going to say return copy, and finally we are going to now call the clone function on the original node parameter we are given. So we are going to now call clone on node. Okay. Actually, we are going to return it. We call it, just simply going to return it because it's going to return the copy of that cloned node. So I'm going to return it. But if the node is an empty node, because it's possible that the input node is empty, what are we going to do? We are going to return it if it's not empty, else return none. Okay. Okay, I hope everything should be fine, and I'm going to run this code now and let's see what we have. So let me run it and let's see what we have at this point. List subject, so I have a typo here, so it's going to be paint. Okay, perfect. So I'm going to run one more time, and you can see it's accepted. I'm going to go ahead to submit. So let's submit and see what we have as well. So I'm going to click on submit here, and let's see. And you can see it works. Runtime was 40 milliseconds, faster than 65.14% of Python 3 online clone graph. Okay. So I'd like to stop here. I'd like to thank you for viewing. And if you have any challenges or some particular challenge you want me to crack, please let me know in the comment box below. I remain Kindson the Tech Pro, and I'm always there for you.